Every day we are bombarded with information that is detected, interpreted, and understood by the body's sensory system. This includes all the senses you and I experience in daily life, like sensory, visual, auditory, tactile, gustatory, olfactory, and proprioceptive. But sensory information's journey does not stop there. Our senses are merely how we detect the world around us. But the central nervous system is how we interpret this information. Now, your brain is subdivided into regions called cortices, and there are dedicated cortices for processing the sensory information we receive from our senses. As an example, when our eyes detect visual stimuli, like this video that you are watching right now, the retina at the back of the eye converts the light signals into electrical signals. Now, those signals transverse into the central nervous system via the optic nerve, where they enter the main relay station of the brain, the thalamus. Now, from there, the signal is transferred to the relevant cortex for processing, the visual cortex. Various features are analyzed, things like shapes, colors, textures, and even motion. The final interpretation of the visual data is handled by a much larger network of neurons, a neural network, which incorporates other cortices that specialize in other functions. The parietal cortex manages spatial processing and attention. The frontal cortex resolves decision-making and response planning. The temporal cortex manages object recognition and memory. Now, the coordinated effort of all of these regions creates our perception of the world around us and facilitate our cognitive responses to our environment. As amazing as the system is, I want to draw your attention onto one region, or cortex, that manages memory. Why memory? That's simple. We forget 80% of new information a mere 7 days after learning it. Think about that for a second. You forget 80% of new information, like that girl's phone number, or your spouse's birthday, or the Colonel's secret recipe, or the secret to YouTube's algorithm. Even though sensory perceptions might be important for our success, we forget. This startling statistic was derived by a famous psychologist, Hermann Ebbinghaus. Now, following completion of his PhD in philosophy in 1873, he proceeded to tutor students. Now, one day, whilst reading a book, he had a eureka moment. The book was Elemente de Psychophysique, translated to Elements of Psychophysics, a book about the thresholds of perception. That is, what levels of sensory stimulation is required for detection of external signals. Now, Ebbinghaus proceeded to pursue a curiosity. Why do we forget? Ebbinghaus used himself as a subject in his studies, and he memorized triplet nonsensical letters to achieve it. Shall we do a quick demo? Let's do a quick demo. Let's see how you fare. In fact, let's turn this into a memory challenge, and we'll see how you fare. I'm going to give you a string of letters, say 24 letters. We'll organize them into groups of 3, like Ebbinghaus did, and your challenge is to spend 30 seconds, no more than 30 seconds. Use whatever technique you've been taught, whatever technique you normally use to memorize information. Okay, here's the letters. Make sure to pause the video when you try and memorize these, but only 30 seconds. Stick to that time limit. Here they are. R-D-G, C-R-H, S-T-O, P-P-A, D-S-X, S-U-U, M-D-D. Now I'm going to give you some time to try and memorize them. Now hopefully we're successful at memorizing those letters. The average human can remember 7 things, plus or minus 2. That means most of us will be able to effectively recall likely all the letters, with a little bit of effort perhaps. But that's not what we're here to talk about. We're here to talk about why we do not all remember the same information, and more importantly, why do we not all use the same method to remember information? That's a more curious question. Now, shall we do a quick jogging of your memory? How'd you fare? Did you manage to find a way to memorize these? Maybe you recorded some notes. Maybe you used the letters to create a song. Maybe you found some sort of word within the letters. Maybe these are acronyms you already know, so you just commit them to memory. Now, all of us are different in how we memorize this information, but there are some core principles here that we need to take away. The first one is that this information would be more memorable if it had a structure. Now, it turns out it had a structure. I actually gave, full disclosure, this string of letters to ChatGPT, and I asked it to randomize them. But for some reason, ChatGPT couldn't complete the task. It kept making errors. It either had a few letters too little or a few letters too many. Maybe that's been hard-coded into its coding. Or maybe it's also making neural errors. Or maybe the forgetting curve is also applying to it. Now, regardless of the technique that you use to memorize these letters, something fascinating arises from this. And it goes back to Ebbinghaus's forgetting curve. 80%. We forget 80% of information, but surely there's a way to trump this. Now, one way that we could trump this is to reflect upon how we would normally boost our memory. The classic is revision. If you revise this information, it will become more memorable. Why? Why does it become more memorable? Well, I'm going to say that reflects a core component of our memory, which ironically enough might have been contained within the book that Ebbinghaus was reading. And that's maybe what got him onto this idea in the first place. Threshold. I'm going to say there's a critical threshold for our memory. Now, if we learn new information and it doesn't meet that critical threshold, it will be forgotten. But if we can manage to boost and attain the critical threshold, if we keep it above that level, then we retain the memory. Okay, so that's straightforward enough. There's a threshold. We need to bump our threshold. But how do we move the threshold? How do we strengthen the threshold or make it easier to remember things in general? Well, you could use a technique. In fact, there are study strategies that you could use that will enhance your memory. And I'm sure most of you probably use one of these. In fact, we already use one called clustering. By grouping the 24 letters into clusters of 3, that's already going to help us to remember it, because instead of remembering 24 digits or letters, we only have to remember 7 groups. That's well within our memory's ability. But truth be told, I actually scrambled those letters. I asked ChatGPT to do it, but it had trouble completing this task. Maybe someone hard-coded that into its coding. I'm not sure, but that's interesting. Here's the original letters that I used to create that randomized list that you had to memorize. Maybe they're familiar. Let's see. First one, RTX. DOS, GPU, CPU, RAM, HDD, SSD. Now those might be more familiar, not to all of us, but to some of us. Those were all descriptors from computers. More specifically, components within computers, and I love how they're all 3-letter acronyms. That's kind of cool. But let's go back through them. What is RTX? Well, RTX stands for a specific brand of GPU, graphics processing unit. That's made by NVIDIA. Now, GPU analyzes visual datasets. So I guess that's kind of like the eyes and or the cortex in the brain, visual cortex, that manages visual data. But there's also the CPU, central processing unit, which analyzes and interprets the data. The CPU does require random access memory, or RAM, in order to store information in the short term. But the information in RAM is quickly deleted because, it needs to be used. If it's not used or stored, the information is lost. So very important, you need to put it somewhere. Where are you going to put it? Well, likely you'll store it on a hard disk drive or a solid state drive, both of which are forms of storage. If the information is needed, where does it go? Well, it's probably going to go to your operating system, like DOS. Yes, DOS has many different meanings, but if you're aware of this one, it's actually an operating system that dates way back. Pre-Windows and Linux and even Mac OS. This goes quite a few years back. But it's an operating system that allows us to incorporate all of those different systems and essentially utilize them to their full functionality. Okay, so why are we talking about computer hardware? How does this help us with our memory? Well, here's the punchline. That string of letters, after organizing the information, is going to be more memorable. There are numerous reasons. We're using clustering, a memory technique, but we're also now creating structure. That means structuring the information might be the single most important thing to do to boost your memory of new information. If there is no structure, like the first list that we did, it's far more challenging. But instinctively, we create that structure, or at least we try to come up with a structure to remember the information. But if we don't have that structure, why does it become more challenging to remember? Why are we more likely to forget? That one's very easy to explain, because when we create a structure, we actually give a framework onto which our memories can latch. And that framework is going to boost the critical threshold for memory. Again, it kind of proves to the brain that this is important, that we need to remember it, especially if you spend a lot of time creating the structure. So that's interesting. But this still remains a random list of letters, so how would we enhance our memory just by clustering it? Well, technically we used another technique, also a memory technique, called memory palace. What is memory palace? That is when we take new ideas and we actually connect them to existing systems that we know really well. So maybe that system is the hardware within a computer, or maybe it's where objects are placed in your bedroom. Or maybe it's the kitchen where you store your cutlery, your cereals, where the fridge is, all of those components. Or maybe it's a classroom at school or university. Or maybe it's a shopping center and where things are stored within the shopping center. Fascinating. Have you ever thought about why shopping centers are so organized and how when they change the order of where things are stored, it becomes chaotic and you can't find the items that you're looking for? In the same way, if we don't organize the information that we store into our brain, it turns into chaos, and the end result is we forget the information. So that's a very important key detail. But at this point, we reach a problem, and this is the same problem you run into with every single YouTube video on the topic: memory. Wait. The videos about memory create a problem with memory? Yes, because at the end of the day, you're still going to forget 80% of this video. Wait, that's a problem. That's a serious problem. How do we tackle this? How can we boost memory, applying some of these techniques, and actually make it useful? I'll tell you what if we link a few extra ideas, maybe like a summary for the secret to effective memory, to our initial acronym, which you thought was useless, but now we know is just a bunch of computer components. Should we test it out? Here it is. RTX stands for recognition, threshold, and experience. DOS stands for documentation, organization, and structure. GPU stands for generalization, attain, and usage. CPU stands for consolidation, processing, and understanding. RAM stands for recall, association, and maintenance. And HDD stands for hippocampus, decay, and database. SSD, space repetition, storage, and distribution. Now, if we play our cards right and we apply our methodologies, we should in theory be able to remember all of those words just by using the acronym that we have just devised. We also have the memory palace because we know the physical locations. If we're well clued up on technology, or at least how computers work, we could pinpoint each of the acronyms within our system. If we can remember the acronym, maybe we can remember the words. Now, we may not remember all of it, but if you manage to remember this information, you will have the secret to memory. Does that mean you can finally trump the forgetting curve? Maybe. Maybe there's more to it. Although we do have to go back to Ebbinghaus's findings, because he added another component to the forgetting curve, which more or less is the solution. It's called spaced repetition. All you have to do to effectively encode this information into your memory, that is your long-term storage, not your RAM, short-term storage, all you have to do is revise this information. Now, you're going to want to revise it in maybe 6 hours, then again in 24 hours, then again in a few days, and again in maybe 5 days, again in 14 days, and again in 28 days. Now, if we can manage to space our repetition, that is the secret to memory. If you're able to pull that off, you will remember this sequence for life. But here lies another challenge. I'm going to call this the single most difficult challenge, and probably the reason why we do forget so much information. Organization. We fail at the basics. We fail to plan our recall of this information. We fail to plan our spaced repetition. So if you are able to plan your spaced repetition, you're going to more effectively remember information. Therein lies your challenge. Now don't forget to subscribe if you've enjoyed the content. Comment in the chat if you found this useful. If you find it doesn't work, also leave a comment. It's going to help us to work towards building a more effective model for our memory. We'll call it our little science experiment. One comment at a time, we can help each other out. How's that for a fair deal? Make sure to subscribe for future videos where I take you through processes that you can apply to improve your memory, your organization, your discipline, your critical thinking, and overall success in life. Take it easy out there. I'll see you on the next video.